Hello friends, welcome to this video. This video is also from the same section of engineering mechanics, that is resultant of a concurrent force, but it is not the direct, it is an indirect problem. So it is little bit trickier than the earlier problem that we solved in previous lecture or previous video, but it is one of the this is also a simple problem. So this problem is like this: resultant of four concurrent forces is 800 Newton. So this is the resultant that is shown in black color, and we are given the three forces. So F1, F2 and F3 are given, and we need to find the fourth force, that is F4 is missing. So let us solve this problem. So solution. So first step is coordinate axis. So let us draw a coordinate axis for this problem. This is really straightforward. So we'll use this as our x and vertical as over y. This goes without saying, but in some problem shifting our coordinate axis towards some force makes our problem easier, but not in this problem. So this is our coordinate axis. Second thing is resolve all the force along the coordinate axis, right? So we'll resolve each force one by one. So this is 45. So if this is 45, this is 400 cos 45, this is 400 sin 45. Similarly, we'll resolve this force. This is 30 degree, so this become 300 cos 30, and this is 300 sin 30. Similarly, this is 60, so this become 500 cos 60, and this is 500 sin 60, and this is our resultant. I'll draw it in different color, so it becomes, oh, this is, yeah, this is too thick, and this is 50. So the 800, I'll zoom out a little, 800 cos 50. Force adjacent component is cos and opposite component is sin, and this is 800 sin. I'll put it here, 800 sin 50. Now what we know about this thing, right? So let us start our problem. So any force is defined by two things. Any concurrent force is defined by two things. First is magnitude and second is direction. But so we have two unknowns, basically magnitude and direction. So we'll write unknowns. Is 2, that is magnitude and direction, or you can also say f4 of x or and f4 of y is unknown. So these are different ways of saying a force. Either you give component or magnitude and direction. So basically we are having two unknowns, and to get two unknowns, it is common sense that we will need two equations. So the first equation is 800. So we are given resultant, okay, resultant is 800 Newton, and second is magnitude. This is magnitude, second one is direction. It is at angle 50 degree, right? So this are the two, this will give us two equation, and we have to solve for two unknowns. So let us write the two things. So the first thing is summation of f of x as usual. So we'll have summation of f of x, that is equal to now let us say the x component of our force f4x is this, and y component is f4y. So we'll write a normal equation, that is summation of f of x Now first of all we'll write a formula for both of these things, resultant and angle, right? So let us say right. So let us start by summation of f of x. Now this is summation of f of x, and that is equal, that is the x component of resultant. So that is Rx, that is x component of resultant, and our x component of resultant is this Rx, and this is Ry. Okay, so we got this thing. So we'll write summation of f of x, write all the forces along positive x-axis as positive and towards negative x-axis as negative. So we'll write summation of f of x, this is first, plus 400 cos 45 minus 300 cos 30, this is negative, and minus 500 cos 60, and the fourth component and the fourth force is f4x, since we are writing the x component of force f4, this is this, and the x component of resultant is plus 800 cos 50. So just solving this thing, we'll get f4x is equal to 741.2 Newton. Similarly, we will write summation of f of y is equal to y component of resultant, and we have summation of f of y as this thing 400 sin 45, this is positive, plus 300 sin 30, this is this force. Now this is minus 500 sin 60, minus 500 sin 60, plus fy f4 of y component of force f4y is equal to ry, which is y component of resultant. Now resultant y component is towards negative x-axis, negative y-axis, so we'll write minus 800 sin 50. Okay, so just solving these things, we'll get f4y is equal to minus 612.6 Newton. This means is equal to 612.6 Newton in downward direction, and this is positive, that means in this direction, right? So this is our x component and y component of force. So I'll just draw this force. This is my coordinate axis x, and this is my y. Now I have x component is positive, I'll draw it in red. This is f4x, and y component is negative, I'll draw it in downward direction, f4y. So our resultant will be something like this. So this is our resultant, this is f4. So f4 magnitude is simple like resultant. We find this formula is similar, f of x square plus f of y square, right? So f4x square plus f4y square, and this is just a plain Pythagoras theorem. So doing all this math will give 961.6 Newton, and now we need to find theta. So for theta tan theta, the formula is f of f4y opposite by adjacent, so f4x, and from this we will get theta equal to tan inverse of this value. So by solving this thing we get 39.6 degree. So final F4 force is 961.6 Newton at angle theta is equal to 39.6 degree, but it is negative, it is in the negative x-axis, so we have to draw this thing like this, or you can simply say minus 39, because clockwise is negative and anti-clockwise is positive. So this angle is positive, and if you go from the in the clockwise action, that is negative. So this is a sign convention. So this is how you write the answer, and that's all in this video. So this video was this problem was little bit twist, was a little bit difficult than the previous problem, but if you know all these equations you will get the solution. So basically in this portion of the mechanics you have mostly 2 or 3 equations, that is summation of f of x, summation of f of y will give resultant, and moment. In the later chapter you have to find moment. So these 3 things you need to remember. Most of the things will come from these 3 equations. So that's all in this video. If you feel that this video is useful to you, then please let me know by pressing the like button, and if you want to see more such videos like this, then please consider subscribing to my channel and pressing the bell notification icon. Thank you friends, take care, bye bye.